Good morning. Yes, Sean, I am. And thanks very much. And good morning to everybody in the room and welcome. Once again, I don't think I've been on a tech talk for, a couple of weeks. So it's good to be back. And it was quite a funny old process to try and get to a topic, because we're running out of topics. So we've spoken about all kinds of things, and I thought I'd just go back to sort of look at it from another perspective and say, well, what is it that I find most often? There's lots of things, but I mean, let's just say, with the drainage situation, what do I find most often the shortcomings and shortfallings of new installations? And there's a misunderstanding, I think, surrounding the connections and the sizing of waste pipes and drain pipes. Now, I know Adrian Myberg has been doing drainage. He is our drainage guru, and I don't want to take his space, but he does the holistic, big old, all the details around everything and the big sort of courses. And I just wanted to drill down to this one specific little thing, which I find very often is a stumbling block, and it's not because we all do it on purpose. It's just that we don't know what the rules are. So here is just some basic rules around how to run waste pipes, how to connect them, and what to size them as. Okay, so it's not a very long one at all. It's, as I say, it's a 20-minute tech talk, so really don't want to get into any other details except for the ones on the screen. Okay, so in stub stack systems, I will start off by saying that there are two basic types of stack systems, right, in plumbing. The one pipe system and the two pipe system. The two pipe system basically has a separate waste stack, and so soil and waste don't mix before they get underground. A one pipe system is the one that we most commonly employ in most buildings, in most applications, because of it's a cost factor, and if properly designed and installed, it can work perfectly well. And that'll also be a fully ventilated system. So the stack, the same discharge stack, also acts as the ventilation stack. So within a system like that, you can have, on single-story dwellings, you can have what they call a stub stack in a home, and that would be a little, and you'll see a picture of it a little bit later. It would basically be a stack which has been cropped short. It doesn't extend all the way through the roof and become a vent. It can be vented, but it is basic. The 110 millimeter portion of the stack is cropped short, and we'll see a picture of that. So in a system like that, what are we allowed to do in terms of connecting waste pipes to a stub stack? Well, if you have an unvented stub stack, let me just grab my little laser pointer. So in unvented stub stacks, no more than one sanitary group may be connected to unvented stub stacks. So that's one bathroom. A sanitary group is a group of sanitary ware. In other words, a toilet, basin, bath, shower. That's a group. It's like you and I and your mate and your mate's girlfriend. We're different people. When you talk about ranges of sanitary ware, now we are saying 6 basins in a row. Like, for example, in a hostel or an ablution block, you've got 3 or 4 showers in a row in a gym. That's a range. And a bunch of basins in a row. That's a range. A bunch of toilets in a row. A bunch of urinals in a row. So so that's just the differentiation between ranges and groups. But in a stub stack system, it's usually employed in dwelling houses. It's usually single story, and they say if it's unvented, no more than one group to a stub stack. If you want to put more than one group, then you need to vent that stub stack, but you may only put 2 groups. In other words, 2 bathrooms. If you're discharging 2 bathrooms into a stub stack, you now must vent that stub stack. There are other rules surrounding whether or not you need to vent, which points need venting and which points don't. I'm not getting into venting today. That's a different kettle of fish, and Adrian is the guru. So if you have a vented stub stack, you may put 2 groups of sanitary ware. The one thing which is commonly misunderstood about a stub stack is that it has to have full bore access to cleaning. That's this arrangement here. Now, how many times have we seen what is deemed or what is called a stub stack, and we've got a vent horn bend coming out of the wall from the toilet with a 50mm vent up top. Never mind the fact that that vent doesn't continue up and stick through the ceiling or is underneath a window or something, which is not acceptable, but anyway, never mind that. And then that 110 pipe goes down and it accepts 2 or 3 wastes from the side. That is not a stub stack. A stub stack must have full bore cleaning at the top. So it has to come out with a junction, 110mm S&V junction, go up and extend a certain amount of distance with an end cap which is removable. If you want to vent that stub stack, the vent must, let me just click, the vent must come off and branch off the side of that stub stack as an offshoot. In other words, you're going to put a junction. Above the junction, you're going to put another 110 to 50 junction, and that junction will then point sideways, and you go upwards, and that junction will be above the level of any other jointed or joined waste or sewer soil lines, obviously. So you want what they call a dry vent. You don't want to have the vent offshoot below any other connections to that stub stack. So that's the basic rules. This is one of the things that I find most often is not in place in stub stack systems, that full bore access. Remember that this stub stack acts as a rodding point. Okay, so it is an access to the drain, which means that these bends at the bottom also need to be slow radius bends and all the rest. We can't put a sharp 90-degree bend there, but that's another topic altogether. Okay, all waste pipes, and this is the second big fall down that always occurs, all waste pipes in a sanitary group must be separately connected to the stub stack. All right, so it says so in the standards. So joining of the pipes within the slab, joining of the pipes as they exit the slab before they join into the stub stack, not acceptable. It has to join the stub stack separately. Okay, so it speaks to better flow, less interference in terms of gurgling and that sort of thing, and back siphonage, etc. So that is another thing that I find quite often is a shortfall. Now, in single pipe systems, I'm not going to talk at all about two pipe systems because they are so uncommon. I don't. They have their own sort of design criteria, and I'm sure they will be for bigger buildings and for higher buildings, and will be designed in such a way as you can follow them. So let's just stick to single pipe systems. If you have a discharge stack to which you are joining waste fixtures, sanitary fixtures, every trap in that system, whether that is if it's joining a stack, I'm not talking about a stub stack, well, stub stack as well, but this, to be safe, but this is particularly talking about single pipe systems, the discharge stack. Every single trap that you install must at least be a P-trap with 75mm depth seal. How many times have we seen that's not the case? Let's think of shower traps, for example. Or it must be a resealing P-trap. A resealing P-trap is, it looks exactly like a P-trap, but it's got a little bubble or a bulge as the U turns upwards and goes, and just before it starts, turns 90 degrees and goes back and starts to discharge. It's got a little bubble or bulge with extra sort of volume in it. And the theory is that as if the trap itself is sucked dry, or dry in inverted commas, there is an amount of water that sits in that extra volume bulge, even though it has, for all intents and purposes, been sort of wanted to be sucked dry. It can't suck that water up, and when the suction finishes, that water then resettles into the trap and seals it. So that's a resealing P-trap. It seals itself again after the fact, or it must be an S-trap with at least 75 mil depth. So that is the only type of traps you may use in an installation if you are joining to a stack. Think about that. How many shower traps do you know are 75 mil deep, right? How many shower traps do you know that have not been joined with any other waste pipe before they enter a stack? Okay, and we wonder why we talk about gurgling and smells and all kinds of things. Okay, there is a requirement that the vertical distance between the lowermost branch waste pipe connection to a stack, to any stack, there's a minimum distance, and you need to bear that in mind. You can't put a waste pipe connection right at the foot or the base of a stack. Now, usually it's underground, so it's not a real problem, but sometimes you have what we call offsets, where you the stack will come down and it's above ground, but it's missing a door, for example, or a window, or whatever the case may be. So you have a vertical piece, then a horizontal piece, then a vertical piece. And that is also the base of that particular discharge stack. And there are restrictions. Okay, so what are those restrictions? At least 450 mil. Okay, that is across the board, and without just excuse me. Without any other type of requirement. But further to that, it must be 750 millimeters if the following is in play. If a stack is 2 stories and more than 2 sanitary groups on each story, right? So that will speak directly to the volume of expected discharge within that stack. So if a stack is 2 stories and there are more than 2 sanitary groups, so we're talking 3 bathrooms on the first floor and 3 bathrooms on the second floor, which is quite a lot of bathrooms. So that's not very often the case. That's like 6 bathrooms, in a thing. So that's not very often the case. Or if it is more than 3 stories and up to 5 stories in a residential class building, in other words, 4 or 5 stories, then it shall be 750, and up to 5 stories in other buildings, right? Then it's 750. But then it must be at least 1 story high from the base of the stack to the center line or the invert level of the lowest discharge pipe if the stack is more than 5 stories high. So if it's more than 5 stories high, you should not ever join any waste pipe or any kind of discharge pipe to the first floor of that stack. Create another stack or a separate set of gullies and soil discharges for the first floor, and the second, third, fourth, and fifth, etc. floors will have a common stack. But don't join the first floor's wastewater to that stack. And we all know the reason for that, because there's a possibility of blockage down the line, and because of the amount of flow through that stack, we can have severe, and it's not even flooding, it's sewer flooding in the lower, in the first floor. Okay, so this distance over here, that distance over there is determined by that point, those points that I've just said. 6.2.3. This, by the way, is from SANS 10252/2, which is the drainage thing. So that distance over there shall be determined in accordance with that 6.2.3.1. Okay. This is also just a nice illustration for you to see what the difference between a sanitary group and a sanitary range is. So there's a whole bunch of WCs or wash basins, and so on. So that's a range. They're all the same, and you can interjoin them, and you can hook them up and they can discharge together into one discharge stack, whereas a sanitary group must all be separate. They are at different heights, they have different flow characteristics, they are apart from one another, they're not necessarily in a nice straight line and all the rest. There's all kinds of reasons why these cannot be joined together. Okay. This is an offset, so basically it is what I said just now, but it can be considered the base of a stack. So there you can see immediately that distance there, the hatched area, is where you're not allowed to join, and we're going to go into it now. But this very first vertical part, or the lowermost vertical part, it says to you again, C 6.2.3.1H. It's the same reference as the previous slide. So the offset, even though it's above ground, is considered a base of a stack, because this stack is the vertical section and that is the base of it. Now, there are additional areas where one may not join discharge pipes into once you've had a change of direction. Why is this though? Because when you have a body of water traveling down a vertical stack, all's well, it will form, it won't take up the entire bore of the pipe. You will be allowing air to be flowing past it upwards in an upwards direction while the water is flowing downwards. But as soon as you start changing direction, now you create waves and you create disturbances in the flow of the water. And for all intents and purposes, the assumption is that you're going to get a plug of water. In other words, the water at some point is going to fill the entire bore of the pipe. And when that does happen, you don't want any waste pipes or vulnerable lines in that area which are susceptible to negative pressure, right? So that's why you've got these hatched areas. Now, what are the rules surrounding those? No connection to the horizontal part of the stack within 2.5 meters of the bend. So there it is, that 2.5 meters there in a horizontal way. There shall be no connection to the stack within 2.5 meters of it turning, of it becoming horizontal. No connection within 450 millimeters of the receiving stack. This is the receiving stack on the right-hand side. So within 450 mil of that, no connections, which is very easy to follow. That's not a very big distance at all. No connection on the receiving stack within 600 mil of the horizontal. In other words, from the bottom of the horizontal downwards, within 600 mil, no connection. It's the same reason, because you've got a body of water which is kind of happy over there, and then all of a sudden it comes across a bend and it's disrupted, and it could form a plug and create negative pressures. Okay, so those are the areas where you're not supposed to join. There is another instance of that, and that is where you have opposing branches, soil and waste branches. If you have a toilet coming in from the left over here, that hatched area over there from the center line of the toilet downwards 200 mil, you cannot join a waste pipe. So if you see a waste pipe and a soil pipe directly opposite one another with some sort of a double junction arrangement, which I've never seen, but if you do see that, it's not allowed. You can either put the waste junction just above that area, or it must be lower than 200 mil from that center line downwards. Okay, now basin discharges very quickly. Basin discharges into a stack. If you've got a basin, no matter what or where it is, if it's discharging into a stack, come on, find your click button. It must have a nominal diameter of 40 millimeters. Now, nominal diameter we'll show you just now, but it is the inside diameter of the pipe. When they, and I'm just going to make it easy. When they talk about nominal diameter, and I've put it in here as it appears in the standards, so there's no confusion. So you can see that the standards, you glance over the standards, you see the number 40, and you assume that it's a 40 mil PVC. It's not. I'm going to make it easy for you. Nominal diameter of 40 means 50 mil PVC, right? Nominal diameter of 32 millimeter means 40 mil PVC. So if a basin discharges into a stack, it shall be 40 mil nominal. In other words, it shall be 50 millimeter PVC. There's no two ways about it. It must be less than 3 meters in length. How many of those have we seen? going
I do
wrong?
apologize, Richard. It has gone 20 past, so I just want to ask that we just start wrapping it up.
Yep, gotcha. Okay, and it shall be less than 3 meters in length. Then it says again, all pipes in the sanitary stack, in a sanitary group must be separately connected to the stack, and there again is just a reiteration of that fact. So basin, when it's connected to a stack, must be 50 mil PVC. Now, what about the other pipes? Well, what does it say? It says here, discharge pipes, and this is not talking about whether it's in a stack or not. This is any discharge pipes. Discharge pipes must be at least the size of the outlet of the sanitary fixture provided, and that in most cases is either 32 or 40 mil, nominal, right? Provided that they are at least 40 mil nominal diameter. So it says to you, it can be any size. So if you've got a, I don't know, 75 mil outlet somewhere, massive big bath, it must be at least that size. But as long as they are at least 40 millimeters nominal diameter, in other words, 50 mil PVC, that puts to bed any questions whether discharge pipes, waste pipes may or may not be 40 mil PVC. The one exception, or the couple of exceptions to that rule, provided it's not discharging into a stack, remember, is that basins, drinking fountains, or bidets, the discharging pipes, if they're discharging into a gully, maybe 32 mil nominal diameter, in other words, 40 mil PVC. But the other rules apply. In other words, can't interconnect them, can't join them together, must be straight, must be, and so that's the criteria. So if you've got a single floor on a ground floor basin discharging straight into a gully, it can be 40 mil, no problem. But if it's going into a stack, 50 millimeters, no two ways about it. Any discharge pipe to a stack shall be nominal 40 mil, in other words, 50 mil PVC. Oopsie, sorry, my bad. I must go back. Okay, well, it's done anyway. So any pipe going into a stack shall be at least 50 mil PVC. That's line drawn in the sand. It's done. So I hope those are probably covered about 3 or 4 often things that I find are downfalls with regards to pipe sizing, particularly pipe routing, the fact that people join it together and are multiple points into one pipe before it joins a stack. And also the stub stack, to me, is often not treated properly as a stub stack with full bore access on the top. So that's me, Sean, a couple of minutes late, but are there any questions?
All right, we do have a couple of questions, some of which are saying here that you have already answered them. So I'm going to go ahead with the first one here. It is, why does a group of sanitary fittings connect into a horizontal stack? Thought you are only allowed to connect into a vertical stack.
No, you can connect into a horizontal stack, and provided you follow those rules and don't connect it within those certain. I'm assuming the person is talking about that slide, the offset. So if you do need to connect into a horizontal stack, these are the restrictions that apply.
All right, and then on what are you allowed to use a 40 mil PVC pipe?
On a basin, on a drinking fountain, or on a bidet, when it is a single story and they're discharging into a gully separately.
All right, 100%. That's all of the questions we have got here for you this morning. Would you like to go ahead and end off from your side?
Just thank you very much to HeatTech once again. Apologies, I don't have any of the logos on this presentation, but it is greatly appreciated. And without the support of guys like that, we can't do this stuff. So that's greatly appreciated. And to PRB and IOPSA are also involved on that side as well. So thanks to everybody involved, and see you next Thursday.
All right, perfect. We have had another question pop up, Richard, so I'm going to go ahead and ask it to you quickly. We have got a couple more minutes. It reads, if a plumber comes across a wrong stack installation, vent direction of flow is wrong, does he write a non-conformance to the developer, and what is not fixable?
Yeah, so the non-compliance or the non-conformance notice is the same sort of requirements across the board, whether we're talking about drainage or geysers or pipework, whatever. The onus is on us as professionals to try our damnedest to rectify what we can. If we come across something and we see, okay, this is wrong, right, so what can I do to rectify it? Forget about the cost, forget about everything. Is there an option at all to rectify this? Well, if there is, or maybe there's 2 options or 3, suggest it, you put it down and you say, look, we can do this, we can do that. This one's going to cost you 20 grand. This one's going to cost you 15. This one will cost you 18 and a half, whatever the case may be. It's not your problem. The money side, it's not, you don't have to pay for it. So just, you have to have thought about it and thought about a scenario in which to correct it and then present that. And then it's up to them. Then they can say, you're crazy. You think I'm going to spend 20 grand to rectify what you say is a bogus valve or whatever. I'm not doing it. Okay, fine. Don't, but then just do so in writing. I've shown you what the non-compliance is. I've explained it to you. I've told you what can go wrong because of it. And I've also shown you what a possible remedy is. You have either said to me, yes, please go ahead, or have said, no, thank you, I don't want to do it. In whichever the case may be, you've done your due diligence. So whether that's a drainage situation or a geyser situation or a whatever, that is your duty. It's not your fault that it is like that. And you mustn't think that you can't, you now have to walk away from issuing a notice of at least a certificate on something. Well, okay, now if it's not your installation, then you can't issue a certificate anyway. But okay, but I'm saying, I'm thinking sort of, I've got geysers on the brain. So if you have to work on an existing installation, for example, and you can't rectify something, there are instances where you can issue the certificate of compliance because you've done something on it, but it will include notice of non-compliance for certain things. The same might apply to a drainage system where you've worked on it, but you're just noting other non-compliances, and at least you've done your homework and you've said to the guy, this is what I suggest, and he's either said no or yes or whatever. And so yes, you issue the notice of non-compliance, but you must also you must do it in a way that is that you've covered all the bases. You've really looked at it and tried to come up with a solution. And so if you can show that you've done those steps, you're 100% no worries.
All right, perfect. Richard, we do have 1 or 2 more questions for you, but I am going to leave that to be answered via email because they are quite long ones, right?
Let's
then,
do one
guys,
because we got 2 minutes. Let's do one. I'll be quick.
We as a plumber had to notify developers many times that HVAC condensation water pipes were joined to the sewer stack. This seems to be a common thing that we encountered on almost a daily basis. We are asked to reroute these many times. All right, so that.
Yeah, that's I've seen that so many times myself. There's an assumption that they can just there's a drainage pipe. I'll just drill a hole, stick my pipe in, and have it protrude an inch into the discharge stack and put some silicone around it, and that's okay. You know, it's it's a big problem.
All right. And then it looks like some of these are for me, so I'll go ahead and I'll answer them via email. But thank you so much, guys, for joining us this morning. Thank you, Richard, for taking the time out to actually prepare and present the session for us. Guys, please do remember the survey on the way out to the session, as it will also ask you for your PIRB registration number. Guys, if you do not, or if you do want to catch up, just a reminder that these recordings do get put up on the app Plumber, so you can go ahead and catch up with them after a couple of days. Other than that, I'm just going to say thanks again to HeatTech, and then to you guys, the audience, enjoy the rest of your week. Bye, guys.